Okay, let's try a couple more practice problems with stoichiometry. So as always, our first step is to balance the equation. So I have 1 copper on the reactants, 1 in the products, 1 silver in the reactants, 1 in the products, 1 nitrate in the reactants, but 2 in the products, so I need to balance that, which then changes my silver to 2 as well. From the problem, I want to pick out what I know and what I'm trying to find. So I want to know how many particles of silver will be produced when 3 moles of silver nitrate reacts with copper. So I'm starting with 3 moles of my silver nitrate, and I want to know how many particles of silver. Particles is kind of another generic way to say atoms or molecules. So for that, we're going to use Avogadro's number. So when we do our conversion, we need to get it to moles, use our mole ratio, and then convert to our final answer. So I'm starting with 3 moles of the AgNO3. Remember, for each of these, we need to have the unit, the number, the unit, and the element or compound. Once we're in moles, we're ready to use our mole ratio. So again, this is our new step. What we're trying to find goes on the top, so our unknown, 2 moles of silver. And what we're trying to get rid of, or what we already know, goes on the bottom. So that's 2 moles of AgNO3. You do not want to simplify the mole ratio, so we'll just keep it like this. So moles of AgNO3 cancel, and now we're in moles of silver, but we don't want silver, we don't want moles, we want particles. So for every 1 mole of silver, we know that we have Avogadro's number, 6.02 times 10 to the 23rd particles of silver. Okay, so that moles cancel, and we're left with 1.8 times 10 to the 24th particles of silver. Okay. So the stoichiometry part of it is just that mole ratio in the middle, this part here. The rest of it is just conversions. So we can do this with molar mass, Avogadro's number, 22.4 liters, molarity, density. Anywhere that we have a conversion, we can add in this mole ratio part to compare different parts of an equation. Let's try 1 more together. So I want to know how many liters of hydrogen gas are needed to react with 10 liters of nitrogen gas to form ammonia, which is NH3. First step, get her balanced. Okay, and then I'm going to put actually into the equation what I know and what I'm trying to find. So I have my 10 liters of nitrogen gas, and I'm trying to find how much hydrogen gas I'm going to need, and I want that to be in liters. So once I start my conversions, my first step is to get it to moles. So since I know nitrogen is a gas, and I'm going to assume STP, since I'm not given any other information, I'm going to use my 22.4 liters. And that's in every 1 mole of N2. So I canceled liters, and now I'm in moles. Once I'm in moles, I'm ready to use my mole ratio. So again, this is our new part here. So for every 1 mole of N2, remember I'm getting that from the coefficients up above, I need 3 moles of H2. And again, that's from the coefficients up above. So moles of N2 cancel, and now I'm left in moles of hydrogen, but I want liters. So for every 1 mole of hydrogen, I need 22.4 liters of hydrogen. And that cancels my moles and gets me to liters. So the answer for this one is going to be 30.0 liters of H2. Okay, now you guys are busy AP students. So you may have noticed that this conversion factor and this conversion factor actually canceled each other out. So the 22.4 is a conversion factor that works for any gas. And so when we do a liter of gas to a liter of gas calculation, we can actually ignore this step and we can just use the mole ratio. It totally works to do it all. But if you're looking to save a little bit of time, when it's a liters of gas to liters of gas problem, we can skip those two steps, just because they cancel each other out at the end. Avogadro's number is also a number that works for anything. It's not unique to the substance. And so if we have a molecules to molecules or an atoms to atoms problem, we can also ignore that, because here we would have the 6.02 times 10 to the 24th, and then on the top we'd have the 6.02 times 10 to the 24th, and they would cancel. If you have any other combination, so liters to grams or molecules to liters, anything like that, you will have to use all steps of the conversion, but it's kind of a shortcut for those ones there. What I want you guys to finish up for tomorrow is the back of your stoichiometry practice worksheet. The answers are posted online for the front of it, so if you check those and then try the back, it'll be due at the beginning of class tomorrow. Have a good night.